Hey, welcome back. This is Tom, and this is Tom's Radio Room Show, and we're going to talk a little bit about one of the kind of unusual amateur radio bands that I seen some reports about it this week and kind of sparked my interest to go revisit it, and that is the 10-meter amateur radio band. I still only have a technician's license. I got my license about 35 years ago, and I really didn't do anything with it. What I was planning on doing is the one band with just a technician's license that you can talk on via voice, sometimes called phone, is the 10-meter band. And unfortunately, the 10-meter band is typically not that active because reception conditions are just poor at that high a frequency, and it starts at 28 megahertz. So it's kind of, well, if you're in the CB world, it's kind of using skip, which is to bounce the signal up off the ionosphere and back down, therefore getting long distance. So it's kind of like that band. And when it's open, it's pretty exciting because us technician operators can talk around the world. It's one band we can talk around the world. Now, some of the lower bands we can use, but typically only for code, CW, which I never did master. Okay, let's talk a little bit about the band itself and its frequencies. Let me zoom in a little bit here. Probably can't read my poor writing. Well, my awful writing, but here is the band plan as laid out by the ARRL, and it varies a little bit depending on where you live in the world. I'm going to go through it quickly. It starts at 28 megahertz and goes up to 29.7, and it's broken down into these are the operating modes you should, not necessarily have to, but you should operate in. So from 28 megahertz to 28.07 megahertz, you should only use CW or code. From 28.07 to 28.15, you should only use RTTY. From 28.15 to 28.19, again, back to code CW. 28.2 to 28.3, you can put a beacon signal out that's continuously transmitting so other amateur operators can use that to find out how conditions are. So that's designated for that particular function. From 28.3 to 29.3 is what they call the phone mode or the voice mode, and it's usually on upper sideband. That's where I want to operate on, right there. Okay, then there's some specialty ranges or frequencies. 28.68 is used for slow scan TV, where you can actually, via your transmitter and computer, transmit a picture. And this is the one I used to listen to many years ago and capture these images. Kind of cool. 29.00 to 29.2 is for the AM users, amplitude modulation, not single sideband. 29.3 to 29.51 used to be for satellite communications. And I actually have, I think I still have it, but the power supply's gone bad. A transceiver that was made by KLH, I believe, or maybe it was KLM, which normally made stereo equipment. And it would transmit on the 10-meter band, and it would receive on the 2-meter band. Pretty unique radio, but it was very popular back then when they first started having satellite communication, amateur radio satellite communications. Now most of the amateur radio satellites operate on 2 meters and 70 centimeters. And there's a lot of them up there. That's another whole subject all by itself. Okay, 29.52 to 29.59 is for repeater inputs. That's where you transmit on these frequencies to hit a repeater, which is typically a station that has a big tower and maybe a big amplifier, so that you can get more range on your signal. It's kind of a remote amplifier for your signal. This is the input frequency. That's where you would transmit to it. At 29.6 was used for FM, typically for simplex, person to person, single frequency. And 29.61 to 29.7 was repeater outputs. So there is where you could listen and possibly hear a distant station, where up here at 28.3 and 29.3, you would listen to them directly, maybe not be able to hear anything. So that is the layout of that 10-meter band. Like I say, I want to try to operate on this phone band right here, 28.3 to 29.3. Now, I have, and I've had for a long time, an ICOM 706 transceiver, amateur radio transceiver, which will transmit, it will receive on all the shortwave band and the 2-meter band and the 70 centimeter band, and it will transmit in those ranges only on the amateur radio bands, which includes the 10-meter band. So I have a transmitter. It's 100 watts that will operate on this 10-meter band. And if you watched my show about a month or so ago, I dug that thing out. I got it working, or verified that it was working. I found a microphone for it. I didn't find the one that I wanted to use, so that's something I got to work on. But I found a usable microphone. Next, I will need a antenna. Now, this morning, for a few seconds, minutes, whatever, I'm going to test using my MFJ analyzer my 3 antennas that I have connected to this connector via switch. So I'm going to hook that up and see how it does on the 10-meter band. Those antennas do on the 10-meter band. Of course, I have to remember how to use this thing. Let me zoom back out just a little bit. Okay, so I'm on, right now, I'm on the MFJ 31-foot vertical antenna. And we'll turn this on. And we'll select sweep frequency plot. And we'll select SWR. And now I have to remember how to change the starting and ending frequencies for it to scan. Okay, start is 130 megahertz. That's where I left it. I want to start it at, well, let's go a little lower. Let's go down to 25 megahertz. And then we want to end at 30 megahertz. Okay, so now it should replot, and it looks like not that great. It's showing right now the cursor is at, oh, I'm sorry, you can't see that. The cursor is at 27.8956 megahertz. A little lower. So let's see if I can move the cursor to, we want 28.3, for instance, somewhere thereabouts. 28, Oops, I went past it. Yeah, about there. Okay. The SWR for this particular antenna, the MFJ vertical antenna, at that frequency is 4.8 SWR. Kind of high. You want to typically have it less than 2. And ideally even lower than that. So not too good on that antenna for that frequency. Now, let me play it safe and turn off this meter analyzer, and I'll switch to a in-fed horizontal antenna that's about 50 feet long. And we'll turn this back on and see how that one does. Okay, we'll go back to sweep frequency plot, SWR, and it should be all set up. And, oh, there's actually a little knee right there. See if I can show it to you. So we're showing 28.29, and the SWR is 3.14. Not too good. Like I said, you want to get less than 2, an SWR of 2. Not too good. So what we can do, I'm not going to do it right now because I'm already up past 10 minutes. What I can do is, let me turn this off. So the 2 antennas I tried, the SWR was a little high. Now, what I do have, and I've done a review of this, I do have this MFJ antenna tuner. And this will help tune the antenna, match the antenna and the transceiver impedance-wise to get something less, 2 or less on an SWR as a built-in meter. This is good up to 300 watts. That the analyzer is only putting out maybe a couple hundred milliwatts. So the more power you put into your antenna, the more the SWR will change. So I can put this in line, and right now I'm kind of leaning toward the MFJ vertical antenna because the peak of that, or the tip of that, is 31 feet in the air above my house. So it's, well, what I'm saying, it's above my house, probably about 10 feet above my house. So I'll hook this, and I'll probably do it directly because I've got the antennas that I showed you are going through a switch. So there's some impedance mismatching there. So I'll take that antenna off the switch, I'll put it into this tuner, and probably what I'll do is I'll check with the analyzer again, the SWR, until I get this tuned for somewhere between 28.3 and 28.9 megahertz for the best SWR. That's about it. So that's what I'm going to do, and then I will be set up for transmitting on the 10-meter band when the band is active once again. So just want to show you that. Again, the 10-meter band is kind of a iffy band. When it's good, it's really good. But most of the time, it's not so good. So anyway, that's the show. If you enjoyed this show, please give me a thumbs up. Thanks for watching. Bye-bye.